Welcome back to this next talk on the studio stage. Before I introduce our next speaker, a quick reminder, tomorrow we will have lightning talks. So if you would like to present a small topic for 5 to 10 minutes, you can still submit that to Anke until tomorrow morning. So don't be shy. Show off what you've got. If you want to practice a little bit your stage presence, lightning talks are a very good opportunity to do so. And now, with great pleasure, I welcome on stage Kloss from Sandstorm, who is going to present.
Hello everyone. Do you hear me?
Who is going to present his.
No, not
package.
his, not mine. It's actually a team effort. So Sandstorm KISSearch is what I want to talk about today. So some technical issues led to me not having my speaker notes on the screen, but it's not that bad because I can remember my first speaker note. It was, "Don't mess this up." So not having speaker notes, the chance went down to not mess this up. But okay, let's get started. So somehow I had animations in here, but let's see. So let me introduce myself a bit. I'm Eric. So funny thing, when you full text search my name in Google, you find this guy, but I'm not a jazz musician. So then you find that guy. I'm also not an ice hockey player. I'm that guy in my free time, at least in my free time. Joking aside, my name is Eric. Programming since fifth grade. It's almost 30 years now. I'm at Sandstorm for like 10 years. In my free time, I'm a musician, and actually, I've never done a tech talk in a tech conference before, so it's my first time. Thank you. Please be supportive. Don't throw bottles at the stage. Okay, let's get into it. So, talking about KISSearch, let's start with the name. It's kind of a strange name. It consists of two parts. The first part is KISS, and the second part is search. So, what is KISS? I guess actually many people of you know what the KISS principle is, right? Is there anyone who doesn't know about the KISS principle? Okay, I will tell anyways. KISS, it's short for keep it stupidly simple, so basically reducing complexity to a minimum in a system or a solution. And the second part of the name is search. In this particular instance, it refers to full-text search. So KISSearch is a package about hopefully simple full-text search for the NEOS CMS. So complexity or simplicity can be seen in many ways or in many aspects. For example, you can have a look at code structure itself to have maintainable code, readable code, code that you will understand after 2 years. But you can also see it in different aspects, like architecture or infrastructure, for example. So in our case of KISSearch, the simplicity refers to the infrastructure part, and hopefully also to the API. Yeah. So a simple NEOS setup actually might look like this. You have a PHP runtime somehow. You have a web server, which takes requests in, and you have a database, which the PHP queries. Let's blow it up a bit. Often we have a Redis as cache backend, or mainly for performance reasons, or to share cache between multiple instances of NEOS, for example. Sorry. And now let's have a look into what's the status quo of current search packages in the NEOS world I know of. So yeah, with Simple Search, who's of you used Simple Search before? Quite a few, or you're shy maybe? So the Simple Search package is based on MySQLite database, which is file system based, and It actually creates a file somewhere in your data folder of the Neos instance. And you have an indexing command, which basically puts the data from your content repository, which is a single source of truth for your content, into the search index. So that's a problem when you have two different kind of data stores, because you have to sync them, right? So what that means for infrastructure complexity is you have an additional part of software in your project, MySQLite. You need to understand it. You need to be able to debug it. Yeah, let's talk big now. The Elasticsearch. The hammer for every screw you have. Basically, yeah, Elasticsearch is a really powerful search engine based on the JVM. So talking about infrastructure, it's an additional knowledge you have to have in your team, or at least your hoster have to have, because you need to host a Java application. So one more dependency isn't that bad, right? Yeah, one more dependency may cost you hours. Actually setting up the hosting, configuring software, understanding the configuration mechanics, understanding the concepts, debugging it in case of unexpected behavior. This is really a hard thing. To debug a MySQLite database which is inside a Docker container where no MySQLite CLI is installed, for example. You get to borders really, really quickly in debugging it in complex setups. Testing is a big issue. You have to mock or even run your real external dependencies in your tests. You need to manage the life cycle of it. You need to reset the state between tests and stuff like this. And of course, you need stuff. So to make an example, this is an image of the amount of time needed to understand Elasticsearch configuration. Yeah, it is really hard, and I felt actually really stupid when trying to do this, because even after weeks, I couldn't get into it. But why? Why is Elasticsearch so complex? What do you think? Just shout in if you want.
Many use cases?
That's a big part of it, yeah. Yeah, because full text search is really complicated. Large number of use cases, my first point, really good. And an interesting part is the result quality is very subjective. Like the same part of software which is deployed somewhere satisfies one customer really well, and another customer is totally disappointed and frustrated using the search bar, for example. We have some students at Sandstorm that are into this topic if you want to know more. So fine-tuning full-text search is also really hard because of the many use cases and the one system that has to serve that many use cases. Okay, so what is full-text search about? Full-text search is kind of a natural language processor, or not processor, but let's say a filter for natural language. So now it would be good to have my speaker notes, but I try my best. Yeah, let's talk about some concepts of full-text search. Like, I had a good, let's see if I remember this sentence. A dog with a tail is nice. Let's imagine this sentence. Like 7 words, only 3 of those words have meaning. I mean, all the other words are necessary to understand the grammar for a human being, but for a machine, all those, I call them, they're called stop words, are unnecessary for filtering. They are even in the way of filtering, because imagine the article the. You go to a full-text search and you want to search for theater. You type T-H-E, you find a lot of crap, but not a theater, because the article the is so present in every text that the boosting will go up naturally if you don't filter out those words. Yeah, they are called stop words. So natural language also has, what are the 2 words? Please tell me. Yeah, right, those. Where the same word is written totally different in some cases, right? Like, can you read, can you read the sentence, please? Search for find and find found, but not founded. Yeah, so there's another concept called stemming or lemmatization sometimes, where the stem of the word is taken into the search index. So you can actually search found and find, for example. So another big topic is prefix search, because full-text search engines often make a big assumption where they say, okay, usually a user will type the word from the beginning of the word, right? I don't search for a part in the center of the word. There was an example, Tobias, can you help me, please? Ah, yeah. Imagine there's a bookstore. You search for books about languages. You start to type L-A-N-G. You don't want to find books about slang, right? So the prefix search pattern is a bit in the way of German compound words, because it's one word or 3 words or 4 words in one word. And usually the meaning is, or the more general word is behind. So when you search for Maschendrahtzaun, or you want to find Maschendrahtzaun and you search for Zaun, you probably won't find it with prefix search. It's still an unsolved problem in the KISSearch package as well. So if you have any idea how to solve this, we even tried to use Postgres and import the Elasticsearch dictionaries into Postgres, and they didn't work so well for most cases. Tokenizing and n-grams, I would skip over it for time reasons. Okay, let's talk about some approaches to full-text search, technical approaches. Like we've talked about Elasticsearch, it's like the one end of the extreme, I think. Really powerful, really scalable, but really complex. So on the other side of the scale, we have like query in a database system, which is really low impact in complexity, right? It's just a part of an SQL query, but it's performance critical. There are some databases and some index types that cover like queries, but yeah, I think if you have 100,000 of entries in your database, a like query will have bad performance, most likely. So in between somewhere, there are relational database systems, like Postgres, MariaDB, MySQL. They have really nice full-text capabilities. And I didn't know about this until like 2 years ago, or maybe, because the database world changed. They evolved, some more, some less, but yeah, Postgres, for example, has a really powerful full-text search engine integrated. Let's look a bit into it. I didn't take code examples for now for those basic stuff. I think you can all Google this in the documentations. It's well documented. But MariaDB and MySQL, there's match against operators, which is basically the full-text match operator, which you can use in a where clause or in a select clause. When you use it in the select clause, you get the score of the match. When you use it in the where clause, you filter, basically. You can create full-text indexes that improve performance for match operations. The warning, I won't read it out, but we come to this later. We had a really nice production incident with a totally unexpected behavior of MariaDB. But let's talk about it later. We have time left. So Postgres is a bit more sophisticated using full text. They have a custom data type called TS vector, or text search vector, which stores already pre-processed natural language in a specific format, which is easy queryable. And yeah, and all the concepts I've talked about before, like stop words, lemmatizing, stuff like this, also happens in a function call in Postgres. So you have really fine granular control about when this happens. And you can even debug it very easily. You can just type select to TS vector my text, and you get some text back. You can see how this function behaves. To-TS query is used for the query input to process it, pre-process it. The add operator is basically the full text matcher in Postgres, and there is a nice index support for performance improvement. The cool thing about Postgres, and I will come to this later when talking about KISSearch Postgres implementation, is Postgres has a dictionary concept. So those two functions, 2ts vector, 2ts query, they have two parameters actually. The first parameter is the text of the natural language you put into it, and the second one is the language, or a dictionary identifier if you want. So you can have the same database indexing German natural language or English natural language, for example, which is really cool, combined with content dimensions in NEOS. Okay, let's talk a bit about NEOS and full text search. So what do we actually want to find in NEOS? No, it's actually not nodes. We don't want to find nodes. We want to find a page, right? We want to find a URL, basically. So the NEOS content repository with its tree structure, I think you all know this. The content nodes are stored below their document nodes. And in most time, we take a big assumption when using this approach to full text search, when searching in the data, not in the rendering output, that the nodes that are below a document are actually rendered below my document. That's up to you. You can do whatever you want in Fusion, right? You can even put static output in Fusion and don't process your nodes at all. But I think that's a kind of far-fetched idea, but I think the more real-world use cases, heavy usage of references. Imagine you have a document in your node tree where you store some kind of data inside of nodes, then you have another document which includes those references. Maybe in this case, searching for nodes will not work because it will give you the wrong document, right? Okay, enough theory. Now it's time for history. It's even more fun. I want to talk a bit about how I got the inspiration for this package and how I got the required knowledge to implement this package. So a few years ago at Sandstorm, we were hired from a customer to improve performance in PHP projects, and it was really, really bad. It was a really big legacy project with Symfony, I think, and with Doctrine. I think you all know those Doctrine dev views or something where you can see how much queries are fired. The bad endpoints really had like 10K SQL queries per page load, which is easily achievable with Doctrine, to be honest. How do you get to 10,000 queries per page load? Yeah, you take a repository, you load a list of entities, you loop over the entities. For each of those entities, you call another repository where you load entities, then you do another nesting level, and you have 10,000 queries. No problem. So what we did is basically we removed Doctrine from those critical endpoints and basically replaced PHP loops with join queries, with native queries. So that's where I lost my fear of large SQL queries. That's a quote actually from Christopher Lubeck. We had a talk a few days before, and it's cool to see that, not to be alone ranting about Doctrine, you know. Okay, so the real-world use case for KISSearch was actually Bosshammer-Schof Ökokiste. Leo, another Sandstormer, had a talk about this last year. Maybe you remember the pictures of the shop when you were there. But yeah, let's say it's a big NEOS project with like 50 instances or so, and there's a big set of content and a big set of custom data, like products. That's basically an online shop where you can buy food. So the products and all the categories and the real complex domain of this project lives in custom flow entities next to the content repository tables in the same database. So yeah, we're thinking, okay, which search package we want to use for this use case. let's use Elasticsearch, and let's look what this means. So we have to install the Elasticsearch package for Neos, which indexes all the nodes, and then we have to write a custom indexer for our products and all our other data, which is next to the products, like categories or eco boxes, like ÖkoKisten. We can order them. So then we thought, okay, maybe this is overkill. Why can't we just write an SQL query that does the same thing? So we wrote a prototype SQL query and like a bit of schema which comes with it. And KISSearch is basically a query builder tool or API for this idea. Because the main requirement was not only requesting or searching for Neos content, but also for other custom search result types. And that should please happen in one query, not only for performance reasons, but also for consistency reasons, like having a common limit or a common order is pretty practical when you don't have to process your results in PHP after you loaded them, or fire two separate search queries and then merge them together somehow by PHP. Additionally to this, there were some other requirements, like eco boxes are their main business. They come with a kind of subscription model. You can get them every week, and products is kind of a one-time buy. So they wanted to have the eco boxes more up in the search results, even if they don't match that well for business purposes. And also, because food is really special it's really kind of special subset of natural language, because, try to tell a search engine that Chardonnay is red wine. No chance. Or cheese and Bavaria Blue and stuff, somehow some crazy cheese names out there. Okay, that all added up and led to kind of shaped the KISSearch package. So the main principles are no additional infrastructure needed. You already have the infrastructure you need for full text search. Why don't utilize it? So a really well idea which came actually from Sebastian Kurfürst was, hey, why don't you make the configuration downwards compatible to simple search? Then you can really quickly switch and don't have to reconfigure your node types. So we did it. So KISSearch is optimized for query time. It's not, by query time I don't mean query execution time, but the time when you run your queries. Another really important feature is no explicit index update is needed, because your full text index is stored in the database. That means it is updated on each insert or update. So KISSearch should be easily extensible with additional search sources. Scoring, boosting, so on. And a really big inspiration of the architecture of the new event source content repository was this kind of idea to make it a composer library instead of a flow package. The main reason was, okay, the event source content repository is usable in your Laravel project, right, as database for content, for example. Why can't you use KISSearch then in this Laravel project as well? That was the idea basically behind it. So it's database and framework independent, at least the core. It comes with some utility functions to utilize the flow mechanics, like settings and dependency injection, but it's only a really small wrapper, really similar to the architecture of the event source content repository. Okay. Let's talk about the main principles of, let's go back for a minute. KISSearch is designed as API package and doesn't come with any logic about finding anything. It only comes with kind of a query structure builder, and the Neos content result type is the first implementation of this API, so to say. So when you want to extend KISSearch with your own custom search result types, you can look into the Neos implementation to have a reference. So, and this comes shipped with the Neos, with the KISSearch package. So what are the ideas? It's very similar to simple search and also to Elasticsearch, where you have buckets, which are more important or less important. So, for example, text that is rendered in an H1 headline is more important than text in a paragraph, for example. And you can configure this behavior in your node-type YAML like you are used to from simple search or the search plugin API. Yeah, another principle is what we talked about, the closest parent document aggregation. If you have any questions regarding this, please ask them afterwards. You can search in different workspaces, so all workspaces get indexed, so to say, and also about in content dimensions. The additional filters were in my speaker notes, so there are quite a few. Like you can filter for a subtree search, for example, or for inherited node types. You can say, I only want my abstract search result node type to be part of the results. You can also do this in the indexing as well, where it doesn't get indexed at all, but you can also parameterize it at query time. Okay, let's look at the search performance, because this is really interesting. I developed the package with a really small Neos instance. So earlier this week, I tried it the first time with a real big project, and I set up the local Neos IO instance with 150K nodes. And to be honest with you, it still has some problems. But to be more honest, not at the query time. When you have installed it once with so much nodes, and I'm on it, I promise this will get fixed soon. But yeah, once it is installed, you have a query time of 15 to 50 milliseconds on average, which feels really snappy in a live search. This is a really ugly example script, which is part of the repository, and we will come to the step how to use it, KISSearch next, but there are quite a few ways to use it, because the one main principle is it is optimized for query time. So you don't need to boot Flow or any framework when you want to fire a search query. So what I did in this example is I printed the search query with a Flow command. I copy-pasted it into a PHP script to avoid Flow booting overhead, and just fired the query to the database, and that's how we get this low response times. Same example, to explain, I typed and every keystroke did a request, and this is a kind of history of the timings. This is the same example for Neos IO with 150,000 nodes in it. So that looks really promising for me, at least, and I still want to figure out what the limits of KISSearch are, because I don't want you to install KISSearch where it breaks stuff, right? Okay, let's talk about development workflow, how to use the package. First, install the Composer package. You have to. It's actually three packages. It's the API core package, the Flow adapter, and the Neos search result type are three different packages. So you decide on your based on your use case which of those packages you install. Then you configure your node types, or they are already configured because you used simple search before. You apply this schema via Flow command, you refresh your dependencies. I will talk about it in a second, what this means. And yeah, then you configure your so-called search endpoints, or you use the one that's shipped with the package. So let's talk a bit about the wording. I think it's important to understand the next points. So KISSearch basically is a query builder tool. And the search query, I do this movement because the search query is quite huge. And the parts of the search query have names. So the first part is the search source. That is the part that does the full text matching. So in Postgres, the add operators, in MariaDB match against. the results are stored in a common table expression. Why we separate it, I will talk about this in a minute. The filter then accesses this common table expression and applies additional where conditions, for example, for the workspace in the NEOS example, or all the other filters. And then finally, you have a type aggregator, which takes all the results emitted by a filter and groups them to your final search result. In our case of NEOS, it takes all the content nodes that are found and groups them to their closest document parent and emits one result for this document. You still have can access the metadata, which nodes matched, because there's kind of a metadata array inside of a search result, and a match count, how many actual search source or filtered entries led up to this one single entry of the aggregator. That can be, for example, used if you want to implement search preview widgets, for example. Then you can see, okay, I found my block document node, but the text was actually matched in a headline, so I can maybe render some part of the headline or whatever. Okay, what is a search endpoint? Search endpoint is basically an array of configuration, how to build the query. So there are query options that influence the structure of the SQL query itself. For example, the content repository ID is one example, because what I've learned is that the new event source content repository, with their projections, they have dynamic table names. So we need to do this as well. And then you have the filter configuration and the type aggregators. So finally some code. Okay. Let's have a look at an endpoint configuration. I called it US Live because, as you see here, the default parameters are workspace live and language US English. So there are a few identifiers like this one, and this one. To be complete, we'll show you the configuration for this as well. This comes with the NEOS package. And basically, it refers to a class which then produces the SQL parts that we spoke about before. In this case, it's it's 3 times the same class because 3 different interfaces for the same class. Okay, let's look at the schema configuration. You don't have to do this. This is part of NEOS already. If you want to fine-tune it, of course you can. So that's why we exposed this configuration. Also two classes, or one important class that creates the create scheme SQL and the drop scheme SQL. And, wrong button again, I'm sorry. I have to wait for the animation to finish. Okay, we're back again. So, and then you have some options for the indexing, for example, the base node type, the base content node type, content repository ID, and excluded node types. Then you have a refresher class, because I was telling you before, you don't need an explicit index update. That's only the half of the truth, because you somehow need information, additional information that is somehow slow to query. For example, the relation of node ID to their closest document node. And this, we do this in the Postgres version of KISSearch that will be done with a materialized view, but we don't have this possibility in MariaDB, so we just have a regular relation. But this relation has to be created, and currently in small projects, this is really performant, and so we can do it on a node publish. But in the instance with 150K nodes, I need to improve the performance of this part of the software. Yeah, and you can refresh your search dependencies with a flow command as well. So maybe for big instances, it would be a workaround to do this once a night or so. Come on. Search query workflow. I want to talk about how you can fire search queries, right? It's pretty straightforward. Take your user input and put it in an instance of search input. You can decide as developer what is actually user input and what is kind of developer input. Let's say, for example, the limit of the query, the amount of results you want to have. You can imagine hard coding it as a developer on the server side, or you have a drop-down in your UI where you can specify the limit, for example. So you put it all in a search input, then you load your endpoint configuration, create an instance of search query, and execute your query with the query tool. Those APIs should be pretty final, so they won't change in the future, I guess. Unless you have a better name for query tool. Okay. To see it in code, you detect your database or you hard-code it. You create your search input, you load your search input configuration, you create the query, you execute the query. If you want to see live examples, please come to me afterwards and we can have a little hack session or whatever. Looking at this, yeah, it's not that framework independent because what is this? And what is this? And what is the instance provider? And what is the database adapter? Okay, let's see. That's what I meant with the flow wrappers. And here there are, oh, I'm sorry. You saw the dependencies. You can inject them, and they are pretty self-explaining. I will skip forward. So the flow commands you see there, most of those are to print stuff, but then you have the schema commands to create your schema, drop your schema, or reset it. Reset is basically drop and create. And refreshes those dependencies, for example, the nodes to their closest document node relation. Print search query is not just for debugging, as I told you. This can be used to optimize query performance when just taking the pure SQL. And query is kind of a CLI search. So what you need to do for custom search results. There are two sides of the medal. It's the write side and the read side. So implement the search schema interface, basically two methods, like you know them from doctrine migrations up and down. They are called create and drop. And for query time, you implement those three classes, which we talked about before, the search source, the result filters, and the type aggregators, which basically produce SQL code. So there will be an documentation for this, of course. Okay, wrapping up the talk, I want to share a bit of my learnings, what I learned implementing this, or updating it to Neos 9. Because it started with a Neos 8 prototype, which was totally different database structure. So I guess I have to hurry. So Neos 9 is awesome, that's all you need to know. No, it's really, it feels like a sophisticated architecture got even better. And that's not because they pay me or something. It's my real opinion. So yeah, one really cool part of it, I pressed the wrong button, is that, or my favorite change actually is that the URL of a document node is stored in the database. You can query it. You don't need the linking service or URebuilder or stuff like this anymore, just as a select query. So MySQL learnings. You can't mix full text index lookups with other lookups like, for example, primary key indexes. When you combine conditions with full text conditions, they lead to full table scans. You don't notice it until your production server starts to burn. And this is kind of a really, really mean thing, I think. MariaDB feels a bit old school. Postgres feels awesome, I think. MariaDB, why this they have way more built-in functions for string processing, for JSON processing, for like everything. And even writing own functions is way easier because you have all the possibilities. You can even write functions that return result sets, like a virtual table with parameters. You have materialized views, which is really awesome concept. So full text queries work really well in pure SQL. Even if you don't use KISSearch and you want to have some inspiration for your own custom queries, have a look into it. Postgres feels more powerful for the full text search mechanics feel more powerful in Postgres. Generated columns are awesome. Do you know about generated columns in SQL? Who knows them? A few. Okay. That's basically a computed column with a few restrictions. You only can access your own row, but it's kind of a nice thing to do when you have, for example, node properties in a JSON and you want only the title to be indexed in a database column. Nice. Do a generated column with a JSON accessor and put an index on this column. This is how KISSearch is implemented internally. If you want to know more about this, just contact me. Alter table add generated column will update all the rows in the table. If you have a real large table and a real complicated generated column, this will crash. Recursive common table expressions are nice for handling hierarchy, you know what I mean, those data structures. And all in all, databases have become really powerful tools, so let's use them. So what's next? 1.0 release start of next week, because tonight is social event. Documentation will be finished really soon. Postgres support, as soon as Neos 9 supports Postgres, right? And I'm really looking forward to it. Maybe we can help a bit out if you want. There's no plan to migrate the current KISSearch API to Neos 8, but if you want to use KISSearch in your Neos 8 project, just use the prototype. It works really well, at least for small projects. Current working status on the branch Neos 9 will be merged with the 1.0 release. Okay, if you want to contact me, I'm not on social media, so just write a letter. And sorry for my sloppy English. Thank you. Thank you very much. And also thanks Sandstorm for enabling me to do this in my working time. That's a really, really big, really big thing.
So we do have a few questions here.
Ah, okay. Nice.
Thank you very much for presenting KISSearch. The first question is from Adrian, and he's asking, do you have a recommendation when to use Elasticsearch and when's a better use case for KISSearch?
Yeah, I think I really want to find this out, the limits of KISSearch. But I think if you need so fine granular control over your search configuration, and if you have the knowledge already in your team, and if you need like distributed systems, or if you need kind of the other functionalities that comes with Elasticsearch, like regular index lookup, you should use Elasticsearch. And I think for now my guess is kind of from 200K nodes or plus, better use Elasticsearch. Or use KISSearch and let's improve it together.
All right, thank you. And the second question. It's about word families. Okay, how are language-specific cases of word families handled?
Not by MariaDB. By Postgres, they have this dictionary concept, and it's really, really awesome. And it has actually the same underlying format as Elasticsearch, so they are compatible with each other. You can install them really easily. So.
All right.
Yeah, I think that's it.
Thank you very much. Don't forget to rate Eric's talk in the NeosCon app. We want to award a best speaker at the end of the conference. And as all the other speakers as well, we have our presents for you.
Thank you.
So thank you very much. Eric.
Thank you. Bye-bye.
And thank you very much. Next up on stage, here on the studio stage, are Martin and Bernhard with their open API specs are a flow controller's best friend, so more flow stuff. And on the main stage, we have graphs all the way down, Neos 9 in action by Michael Löw. So, 10 minutes to go. Enjoy your break and see you back in 10 minutes.